Well, we'll learn something on Monday about slope, but this is the last time you're going to use these notes. All right? Slope, gotta get all these things lined up here. Slope can be found from a table. Okay? When you're given a table or a set of values, and they don't always identify your set of values by X's and Y's, and that's just that's just them saying, hey, you should know, you should know. You can also find your y-intercept most of the time from a table. So, box from a table. Box the two middle points in the table. What do I mean by that? I mean, if I have a table which is right down here, I got to turn this, okay? I've got 4. If I had 3, I have 5. Just pick 2 that are kind of in the middle, all right? That is your best bet. So I'm going to pick 2 in the middle, okay? It says find the constant rate of change, which is what? The slope of the X and Y values, and write the change as, and you will see this, the change in Y over the change in X. Now, what you're going to do, at least initially, and probably some of you will need to do it forever, all right? You are going to use your famous formula. y2 minus y1 over x2 minus x1. So we're just going to concentrate on slope for a minute. So if I use my formula, do you see, when you have a table that is laid out like this across, your X's are always on top and your Y's are always on the bottom. I don't care if they don't say X and Y. If it says shoes and toes, okay? If shoes are on the top, they're representing your X, and if toes are on the bottom, they're representing your Y. So that's what's confusing. You can get confusing by this. So this is my X1, Y1, X2. See, I just got confused, didn't I? That's my X1, X2, Y1, Y2. See, I have an X1 and a Y1. These are actually a coordinate pair. This is your coordinate pair, and you don't have to, 0, 2. This is your coordinate pair, 1, 4. Okay, so it's actually a coordinate pair, but I wouldn't rewrite them because, I'm lazy. I would at least use the table and identify them, though. Okay? Next thing you're going to do, so this is our X, even though it's kind of hard to see up there. Next thing we're going to do the change in Y over the change in X, right? I said the change in Y over the change in X. So I've got Y2, which is 2, subtract, no, I'm not, write your pattern down first, then put your numbers in, always. So I've got Y2, which is what? Not 2, what is it? 4. I've got 4 subtract 2 over, what's X2? 1 subtract 0. You come over here, you do the same thing you did yesterday. 4 minus 2 is what? 2. 1 minus 0 is 1. 2 over 1 is already simplified, and my slope is 2. Okay? So there, my slope is 2. To find the y-intercept, and I wish I had a little more room on here, and I am going to find a spot. Unfortunately, I'm not sure. I need to get that changed for next year. All right. I'm going to do this. Up here, I'm going to draw a coordinate grid. This is my y-axis. This is my x-axis. Okay? Anytime I have a line, I don't care where that line is. If it's here, if it's down here, if it goes this way, whatever way it goes, when I cross the y-axis, what is the value of my x-coordinate? Who said it? Very good. Okay. So I will show you an example on a bigger piece of paper like this. Okay. If this is my origin right here, okay, that's my origin right there, correct? The value is x is 0, y is 0, correct? Okay, so anywhere I cross this y-axis, no matter where it's going to be, whatever point I chose on that y-axis, my x value will be 0. Therefore, I can identify my y value in a table by looking for my x value that is 0. And that's what this says up here. See if there is an x in the x column. If not, use the pattern to work backward to find where the 0 would be. Identify the y value that goes with the x value. That is your 0x value. That is your y-intercept. So in this table, when x is 0, y is what? 2. So your b value is 2. It's that simple. Okay? So that is your y-intercept. All right? Now, some tables, like I said, are going across. You see more tables going up and down, don't you? But occasionally you will see them across. So, following what it said to do, box the 2 in the middle. Okay? I've got, these are my x's, correct? So I've got x1, x2, y1, y2. I have 2 coordinate pairs. I have an x and a y and an x and a y. So I'm going to do my formula. In a minute, I will show you, we're just going to do it this way. And maybe on another day, I'll show you another way you could do it. So y2 is what? 12. And y1 is what? 16. X2 is 9. X1 is? So 12 minus 16 is what? What? Negative 4. And 9 minus 6 is 3. I'm going to see if I can simplify that. Negative 4 divided by 3. Math, enter. And what do you get? Negative 4 over 3. So that is my slope. Negative 4 over 3. Now, this is a much more complicated process to find your y-intercept. And so we're going to do it, but it's going to be tricky to show you on this, but we will because it's just so small. When I go from 12 subtract 9, how much is that? 3. Okay. When I go 9 subtract 6, what is that? 3. So this 6 subtract 3 is 3, correct?
Yeah.
This is consistently going down by 3s. So if I go 3 subtract 3, what am I going to end up at?
0.
X is going to equal 0. Okay? So the next one down after that is 0. Here, if I go 8 and I want to get to 12, what am I doing?
4.
Am I adding or subtracting?
Adding.
See, here I was subtracting, right? Okay. Here I'm adding. Okay. So 12 to 16 is 4 also, isn't it? 16 to 4 is what? 4 is 20. So 4 plus 20 is what? 24. Where is my y-intercept? At 24, because x is 0. Therefore, my y value for where it crosses the y-axis is 24. Now, some of you may notice something. Okay? And this is what I was saying before. I really don't want you to use this not until you are really like, I got sloped down, I never get it wrong, I can cheat the system, right? Negative 4 over 3 is the same thing as 4 over negative 3, isn't it? The change in the y values, y over x, right, is what we have. The change in the y values over the change in the x values is your slope. Look at that. But you've got to make sure that you're consistently going down, okay, by the same amount. So it's better and more consistently correct if you will use the formula y2 minus y1 over x2 minus x1. And that's why we teach you that, because you've got to be a little more sophisticated to be able to get that right. You always have to go backwards, okay, as you're working. All right? So that's all there is to this. I'm going to give you some tables to practice with, and that is going to,
Not be a grade.
the tables I give you will be a grade.